we're going to skip around all the way to 5.6. So we're doing 5.6 before we do all the other ones itself. Okay. So 5.6 is called System of Inequalities and Linear Programming. Now, linear programming, if you're wondering, means computer language. So we're actually learning what does a computer language actually deal with. And it's not robotic. What I mean by computer language is mostly how does a computer do math itself, because it's a little different how a computer does math. Even a calculator does math a little different than we actually do it as well. Actually, even actually see it when it comes to it. Okay. So before we actually get too much in this section, the main concept is we're going to talk about inequalities. So if you guys remember what inequalities mean, right? It's the less than, greater than, and less than or equal to ones, right? So those four type of inequalities. Okay. So now what we're going to do is we're going to graph using those types of inequalities. Okay. But before we do that, let's just graph a simple one. So we're going to graph all three types when it comes to it. So the equal sign, less than, and the greater sign, right? So we can see the difference between one and each one itself. Okay. So just going to go back a ways, go back to the first exam, right? How to solve this. So I'll just make it easier. I'll just do a little t-chart. So I'll make a couple numbers, so 0, 1, let's say 2. So plug in 0, gives me -1. You plug in 1, 3 minus 1 is 2. Plug in 2, that's 6. 6 minus 1 is 5, right? And you can use slope, y-intersect, whatever you prefer, right? It really doesn't matter. All the techniques we used before. So 0, -1, 1, 2, and 2, 5. There we go. There's our line. Right? So that's what we did way back in chapter 1 or 2, I believe, when it comes to it. Chapter 1. Okay. All right, so what's the difference between this and what we're doing now? Okay, and there's actually only two differences, believe it or not. Okay, so believe it or not, all you care about, the one difference is this is the symbol itself. Okay, that symbol tells you if it's going to be a solid line or a dashed line. Okay, now what I mean by solid or dash is if you have the equal sign at the bottom, it's going to look just like this, a solid line. If I have the non-equal, so it's literally a strictly greater than or less than, it's going to be a dashed line. So what I mean by dashed line is literally it's going to be a dashed line looking like that. So think of just little dashes in between here. That's if we had just the regular portions. Okay, but the good news is since they both have equal signs, they're going to be solid. So looking just like that. So what I'm going to do is going to copy it here again, and on the other side as well. Since we know they're both solid because they both have equal signs there. Right, so that's the first difference. It's either solid or dashed, and again, that depends on the sign itself. Okay, let's look at the sign. Okay. The next step is, well, we want everything, so for this one, we want y to be less than this value. Okay. So what we want to do is we're going to do a test point. Okay. And a test point is anywhere on the graph except on the line itself. Okay. And usually 0, 0 works because it's usually not on the line itself. But 0, 0 is pretty close to this line, so I'm going to make it a little different. So I'm going to use the test point. And again, you can pick any test point you want, not on the line. So I cannot stress that enough. It's not on line. So you have infinite number of test points you want. Or you could put like -5, 0. You could put 3, 0. You could put 4, 0, except the ones on the actual line itself, right? So I'm going to pick the number right here. That is -2, 0. Right? That's the point, -2, 0. And what I'm going to do is I'm going to plug in -2 and 0 into here and see, is it a true statement? So let's check. So remember, this is just a review, right? That's x and y. So plugging it in respectively for each case. All right, so this gives me 0 is less than -6 minus 1. So is this a true statement? Is 0 less than or equal to -7? And everybody should say a definite no, right? This is not true. That's a false statement. So what that is saying is, believe it or not, every point I choose on this side will make it false. Therefore, by default, everywhere over here will make it a true statement. And you can actually test it. You could plug this point in, that point in, that point in. That will make it a true statement. So that's the best part is you only have to use one test point, because at that point, it's either going to work or not. It's like a flip of the coin. If it works here, you're good. If it doesn't work here, therefore the other side is going to guarantee to work. And so now we know that this side is all going to work. So what we want to do is we're literally going to shade the entire side of this. So that signifies that this whole side works. So these are all the values that make this a true statement. And then therefore you guys probably already know what's going to happen over here. So same thing, we'll use the same test point so you can see what the difference is. So again, I'm going to plug it into here. So it's going to be 0 is less than or greater than equal to this time. 3 times 2 minus 1. So I get the same thing. So now it actually is a true statement, right? 0 is greater than -7. So therefore now I'm going to be shading everything on this side of the portion, because then this is my point I tested on. It made it be true, so all of these are correct. And there you go. And that's it. That's what we're going to be doing in this section for the first part when it comes to it. Questions so far? No questions? Good. So let's try a couple. So let's graph each. Let's do one here. So let's graph y is greater than or equal to 5x plus 2. Okay. All right, so same thing, right? You can use however you want to graph. I'll just do the simplest one and just make a little t-chart, right, when it comes to it. And I'll use this a couple numbers. So I'll use a -1, 0, and 1. Get me started with this graph. So plug in -1, that's -5. -5 plus 2 is -3. Plug in 0, that'll give me 2. You plug in 1, that's going to give you 7 out. Okay, so just now we're just going to graph it. Okay, so -1, -3, 0, 2, and 1, 7. And since we have an equal sign, it's going to be solid. Okay. And now I'm going to pick the test point 0, 0, because it's right here. So 0, 0 is right there. So it's either going to shade this side or that side. So I'm just going to test it and just plug it in, right? So I'm going to plug in 0, 0 into here. So is 0 greater than or equal to 5, 0 plus 2. And simplifying that. So is 0 greater than or equal to 2? And that is a no, right? That's not a true statement. So therefore, nothing on this side works. So by default, I'm going to shade the other side. So these will all work on this side. There you go. Questions here at all? Not too bad. Okay, let's keep going. Let's do a couple more. Let's try this one. So this one, unlike the other ones, right, are not already in y equals. So we first have to put them into standard form, right, or slope intersect form. So in other words, we're going to solve for y. So I'm going to bring 2x over. And then divide everything by -4. All right, see if you guys remember. What happens when you divide by negative when it comes to inequality?
The sign changes?
Yep, you flip the sign. So it actually is now less than. Good job. Keep going. So this is now positive 1/2 x. And this is now -2. So just be careful of your sign changes when it comes to this one. So now we can finally learn how to do the graphing here. Okay. So same thing. I'll just make a little t-chart since I'm using those. So just keep going. So I'll just use 2, 0, 2, and -2. Okay. All right. So you plug in 0. That's all gone. So we just get -2. You plug in 2. 2 times 1/2 is 1. And 1 minus 2 is just -1. And then just do the opposite. So now -2 times 1/2 is -1. That's going to be -3. And same thing. Now we just graph this one out. So 0, -2. 2, -1. And -2, -3. Okay, and now this one is a strictly sign. So it means it's going to be a dashed line. Looking like that. And same thing, I'll use the test point 0, 0. So if I use the test point 0, 0, does it work or not? So in other words, am I going to shade above or am I going to shade below? Try it out. Go for it. Give you guys another 30 seconds. Okay. Well, it's only 50-50, right? It's to the up or down, which is a cool thing. So if you plug this into here, we're going to get 0 is less than 1/2 times 0 minus 2. And this is not a true statement, right? 0 is not less than -2. So, yep, so we're shading below, or yeah, you can say to the right. Yeah, that's technically to the right. So it's going to be shading all of this. There you go. Okay. Okay. So let's just do one more for practice. So y is greater than negative 4x minus 3. Okay. So get each one. So I'll just put 0, 1, and negative 1. I don't want to go too high of numbers. So if I plug in 0, I get negative 3 out. Plug in 1, that's going to be negative 7. Plug in negative 1, that's going to be positive 4. And positive 4 minus 3 is positive 1 out. All right, so I got my couple points. So let's graph this. Okay. All right, so first point 0, negative 3. Positive 1, negative 7. Way down here. And then negative 1, 1 there. And again, it is dash line. Dash line going this way. Okay. And same thing. Now we just do our test point. And notice, like I said, right, usually 0, 0 is always a good testing point when it comes to it. So plug it in, we get 0, plug in 0, and see what we get. So that's gone. And that's true, right? 0 is greater than negative 3. So this time we're going to be shading on the side. And there you go. So any questions on graphing inequalities? No? Everybody comfortable? Okay. Now, hopefully you think, oh, this is pretty easy. Well, just like in math, everything gets a little more complicated, right? So what's the point of doing this stuff, right? So we're talking about computers and what the computer languages. Now, let's do an example looking like this now. Now we have two portions we got to talk about. So we want to graph the solution set of this set. So now we got to figure out what numbers do they both work for both of them at the same time, right? Well, it's actually not that bad. So what we're going to do is we're going to graph each one individually and see where they come into play, okay? So we'll just graph the first one here. So I'll put that's x plus y is less than or equal to 4. And I'll just graph the other one over here. So the next one's going to be x minus 2, y is greater or equal to 6. Okay? So again, in other words, I'll make a t-chart for each one individually. Okay? So first off, we have to solve for y. So I'm just going to subtract the x over. So we get that on this side. Okay, so now just make again just the t-chart, right? So it gets be consistent. Okay. And again, I'll just plug in some numbers. So I'll plug in 0, 1, and 2 for starters. Okay. So plug in 0, just give me 4. Plug in 1, that's negative 1 plus 4, that's going to be 3. And if plug in 2, that's negative 2 plus 4, that's going to also give me positive 2 out. So notice, same thing we did last time, right? Last 3 examples. All right, now I'm just going to graph it. So first point is 0, 4, 1, 3, and 2, 2. Okay. This one had equality, so it's going to be a solid line. So I'm trying my best to go like that. Okay. All right, next up we do our test point. And I'll use 0, 0 again, right, to see. So if I plug it in, I'm going to have 0 is less than 0 plus 4, and that is H27, right? 0 is less than 4. So that's good. So now, instead of shading everything, what I'm just going to do is just do little dashes like this. So I know this side is going to work. Okay? And you'll see why I do that in a little bit. Okay? So I'm not going to completely go crazy on the shading. I'm just going to do little dashes to tell me on this one, we're good down there. Okay? All right, now let's do the same thing for the next one. So again, this one a little bit more work. We have to solve for y. So let's see. So subtract x and divide everything by -2. So as we all know, when we divide by negative, you flip the sign. So now we have that. And again, now we just graph it. And again, just being consistent, I'll use a t-chart. So I'll use 0, 2, I'll use 4 too. So you plug in 0, that's gone. So you get -3. You plug in 2, 2 divided by 2 is 1, and then 1 minus 3 is -2. Plug in 4, 4 divided by 2 is 2, and 2 minus 3 is -1. All right, so on the same graph, we're gonna plot this one. So this one is 0, -3, +2, -2, +4, -1. And again, this is also solid because as equal sign there, right? So this is also a solid line doing this. Okay. And now same thing, we got to do a test point. So I'll use the same test point, 0, 0. And now see what happens. So we're going to get 0 is less than 0 minus 3. And this is not a true statement, right? So 0 is not less than -3, which means on this graph, we're going to shading down. So again, I'm just going to be doing lines like that. Okay. All right. Now we did both. First one's the pink one. This one down here is the blue. Now, the real solution set is where the both colors overlap, and only where both colors actually overlap. And notice the only time they overlap in these 4 parts is the bottom one, right? This is the only one. So actually, now you can go back and say this whole thing is the real solutions for both of them here, and only this one here. So that's how you solve for a system like this. You literally graph each one individually, do your work, and where they both overlap the shadings is the actual one. And again, notice it's going to be one of the 4 parts itself. It's not going to be a whole 2. It's going to be one of the 4 parts itself. Okay. And that's it. That's how you solve for a little system of inequalities just like that, by graphing. Any questions? No? Is everybody comfortable? What we just did? Good, good. Okay, so to finish off, I want to show you guys why this is so important in the real world. So this is a simple little example to show you guys what's happened, what it does, or what a computer can really generate to help when it comes to it. Okay, so let's suppose we have an example here. Let's suppose earthquake victims in China need medical supplies and bottled water. Each medical kit measures 1 foot cubed and weighs 10 pounds. Each container of water also is 1 foot cubed and weighs 20 pounds. The plane can carry only 8,000 pounds with a volume of 6,000 feet cubed. Each medical kit will aid 6 people, and each container of water will serve 10 people. How many of each should be sent in order to maximize the number of victims aided? What is the maximum number of victims? Okay. Now, this is actually a real world scenario that's happening, right? If this happens, a big case of emergencies, again, we have this big airplane. We have a bunch of bottles of waters and medical kits. Well, obviously you can just dump as much as you can, but a plane can only carry so much. So the question is, how can we survey the, save the most amount of people, with this optimization stuff? So this actually is a huge scenario once you go into higher mathematics. And again, this is the reason why computers were, correctly invented. You type in the information and boom, the computer can spew this out itself. And again, it's all going by this process here. Okay? So let's actually try this one out, okay, just for when it comes to it. All right, so we need to divide some variables, okay? So let's say X is going to be the number of medical kits. And let Y equal the number of containers of water. So the amount, so how many we actually have, okay? So now we got to figure out some equations. So kind of like up here, what equations are we dealing with, okay? So we know this plane can only carry 80,000 pounds, right? And it tells me that the medical kits weigh 10 pounds and the containers of water weigh 20 pounds. Okay? So we know 8,000 pounds must be the maximum it can be, right? So there's nothing can be anything greater than that. So the amount of weight can be less than that, that's true, but it can never exceed 8,000 pounds. That, the plane's not going to fly. So we have an inequality. Okay? So what do you guys think? How are we going to write this equation? So how do we write with the number of medical kits and how much it weighs to figure out how much the total weight is in this airplane? You guys have any idea?
Uh, 6x plus 10y.
Close. So we're not using the aid yet. We're just looking at proper weight. But you're on the right track.
Oh, the 10x and 20y?
Yep. So be 10x plus 20y. Because this tells you how much the total weight is of the medical kits. And this is the total weight of how many the containers of water is going to be. We know that total weight cannot exceed the 80,000 pounds there. Okay, so that's one of the equations. So it's kind of like what we have up there. Next one, we talk about volume. So if you know what volume is, right, how much, if you have a room, like if you have boxes, how many boxes can fill in there? That's what a volume represents, how much space is being occupied by that. But this one's a little easier because it says 60,000 or 6,000. Again, cannot be greater than both of them combined. And that's just because we have one each. So that wasn't too bad. That's a nice one. Okay. So there is our system we have to solve for. Fun stuff, right? But again, all we're going to do is the exact same thing we did on top. Graph each one individually and see where they overlap. Okay. So let's do each one. So this one we can just solve for x. So it's going to be y is less than or equal to negative x plus 6,000. And then the other one, we can solve for x, or solve for y in this case again. So we have 20y 80,000. And then divide everything by 20. So we get negative 1/2 x. And I think it's 40,000. No, 4,000. Yeah, 4,000. And now we can do the same thing we did above. So make a little t-chart. So I'll just do 0. What's in that? Oh, 60,000. So if I plug in 0, I get negative 6,000. If I plug in that, I get 0. It's not too bad. Okay. All right, let me get another sheet of paper out here. So if you're wondering, I really have to graph this, remember, you can scale it however you choose. It doesn't have to be like ones and twos, right? You can go into thousands if you like. So we're going to go, so instead of 1, we're like 1,000, 2,000, 3,000, and so forth. Make it easier for ourselves. So first point is 0, comma, negative 6,000. So it's down here. Oh, no, this is the opposite. That way. There we go. That makes way more sense. 1, 2, 3, 4, 5, 6. So 0 positive 6,000. And this, oh, I'm really messing up today. 1, 2, 3, 4, 5, 6, 0. There we go. So again, has that. So we can make a line roughly like that. And again, we're just going to use a test point, and we can just test point 0, 0 to see if it's true. So if I use this test point, so 0 is less than minus 0 plus 60,000. So that is true, right? 6,000 is greater than 0. So again, since we have 2, I'm just going to shade this part. And now do the same thing on the other side. Make a T-chart. Plug in some numbers. So I'll plug in 0. That's a good number. 8,000. And yeah, I think that would work. So plug in 0. That's 4,000. Plug in that. So it's going to be negative 4,000. So that's going to be 0. There we go. Okay, so now for this one, be 0, 4,000. So 1, 2, 3, 4 right here. And then 8,000. So way out here. So 1, 2, 3, 4, 6, 7, 8,000, 0. So again, it is a holy, so it's going to be solid. Okay. And same thing, test point. So I'll use the same one, 0, 0 as a test point. So if I plug in 0, and then plug in 0, and it's also true. 0 is greater, or sorry, 0 is less than 4,000, so it's also on this side. So now that we have that going on, the question became, now we can go back to the actual question itself. So the question said, how many of each should be set in order to maximize the number of aids, right? All right, here's a fun fact. What does it mean by maximize? What does that word mean? Anybody know? Anybody have an idea what the word maximize means? No? Highest, good. At most, the highest, good. So what's the number that gives you the most possible 80, right, when it comes to it? Okay. So for this one, we have a couple points to actually deal with. So we always want to figure out, so we want this portion here. And we have this spot where they touch, this spot where they touch, and also this spot right here where they touch. So we want to figure out these 3 points here. So the first point is 0, up 1, 2, 3, 4. It's 4,000. This one here is 1, 2, 3, 4, 5, 6, 6,000, comma 0. And this point here is up approximately, so I'm a little off. 1, 2, 3, 4 should be 4. And 2, yeah, just 2,000. There we go. 0. 4,000, comma 2,000. Okay. So all we're going to do is now go back to the situation we had here. Okay, so 6 people get aid for every medical kit. So we know 6x works, plus we know 10 people get help for every container of water we have. So now the question is, which one of these 3 points gives you the biggest number we have? So I'll let you up to you guys to do this for the last extra credit for today. So out of these 3 points, when you plug them in, right, so 0 for x, 4,000, and so forth respectively, which one of these 3 gives you the highest number possible? Go for it. Give you guys another 30 seconds to try it out. Right, looks like everybody got it. Yep, so it's the middle one, right? The 4,000 and the 2,000. So when you plug it in, we're going to get 44,000 people that were aided. Compared to, like, I think it was like 4,000 and 36,000, right? So that's how this is used in the real life scenario. So when it comes to like building the equation and actually finding that. So again, we don't do this nowadays by hand, but this is what a computer software actually plugs it in. It's like, we have this situation, that situation. So what spits out is this in a computer, and bolts it and it just tells you which one is the most optimal, and actually tells you which one is the most minimal as well. So the smallest as well when it comes to it. So that way they know